Hello everyone, welcome to my channel on data analytics. I am your host Professor Rage Uday Kiran. In this video, I am going to describe what is a geo-referenced databases and how to create them. The outline of my presentation is as follows. First, I will describe what is a geo-referenced database. Next, I will describe what is a neighborhood file. Then, I will be explaining you different types of geo-referenced databases that exist to capture the real-world data. Then I describe the rules to create a geo-referenced database and a neighborhood database. And then I will also give an example on how to create a geo-referenced database using a real-world multiple sensor data. And finally, I will provide a small demo showing how to create a geo-referenced database. Coming to the geo-reference database, first we have to understand what is a spatial item. A spatial item is basically any item that has location information. For example, a sensor fixed at a particular place, say point 0 comma 0, represents a spatial item because it is at that point of time. Similarly, an autonomous vehicle at a particular point in time also represents a spatial item. A spatial item is said to be a stationary spatial item if its location do not vary over time. So in this case, the sensor which we have fixed at a particular point represents a stationary spatial item, whereas the vehicle which moves over time at different locations does not represent stationary spatial item. Now, to create a georeference database, we need to collect the data from several stationary spatial items. For example, here we have several sensors measuring PM2.5 values at different locations. If the sensors remain at the same place and gather the data, say PM2.5 values, then the data generated by it represents a geo-referenced database. We now discuss what is a neighborhood file. Two spatial items are said to be neighbors if the distance between them is no more than the user specified maximum distance. For example, let us consider three sensors that are located at point 0, 0, point 0, 0, 0, 1 and point 0, 0, 2. Means these sensors are located on a straight line. Now, if we consider the Euclidean distance as a distance function, then the distance between the point 0 comma 0 and sensor at point 0 comma 1 is 1 unit. Similarly, if we measure the distance between point 0, 0 and point 0, 2 sensor, then the distance is going to be 2. If the user specified maximum distance is 1 unit, then we say that point 0, 1 is a neighbor of point 0, 0 sensor. Whereas The sensor at point 0.02 is not a neighbor of the sensor located at point 0.00. So this information we store it as a neighborhood file. In this file, the first item represents the reference item. The remaining items represent the neighboring items. Now, let us look at how to create different types of geo-referenced databases. As we have discussed in the previous videos, we have basically have transactional databases and temporal databases, which are binary databases. For these databases, we have utility databases, which are non-binary by nature. For these data sets, if we add the spatial information in the form of geo-referenced data, then we get four types of databases. The first one is geo-referenced transactional database. The next one is geo-referenced temporal database. The third one is geo-referenced utility database, and the last one is geo-referenced utility temporal databases. We now briefly discuss each of them. A transactional database is basically a collection of transactions where each items are separated with a separate. If you the example of a transactional database is shown on the left side with the title Sales Transactional Database. If you are not familiar with the transactional database, please check the link provided above. So for this database, if we add spatial information, then the resultant database is called geo-referenced transactional database. As you can see here, in the transactional database, we have items, whereas in geo-referenced transactional database, we will have the information about stationary spatial items. Now, coming to geo-referenced temporal databases, these are also temporal databases with spatial items. If you are not familiar with temporal databases, please check the link provided above. So, in geo-referenced temporal databases, the first element in a row must always represent timestamp. The remaining items represent stationary spatial items. As you can notice, geo-referenced transactional and geo-referenced temporal databases are only storing the binary data. To store non-binary data, we use geo-referenced utility transactional databases or utility geo-referenced utility temporal databases. So if we are referring to geo-referenced utility transactional database, then it is same as utility transactional database, but instead of items, we will have spatial objects as shown here. So please note that the format remains the same. Only thing is the items are replaced with spatial items. Now, if we have to store the temporal information also. We can store the temporal information in the first as a first element in a line. Now let us look at the rules to create a geo-referenced database. Rules to create a geo-referenced database are same as the rules to create transactional, temporal, and utility databases. Also, please note that a spatial item can represent a pixel, a point, a line, and a polygon. So, a spatial item can be anything among these four types. Now, when we create the neighborhood file, what are the rules to be followed? To create a neighborhood file, we have to follow the following four rules. First one, every row contains items and its neighbors. Items and neighbors have to be separated with a separator. Most important point is the first item in a row must always be unique because it represents a referential item. The remaining points can be neighbors and duplicates can exist. Then, when we are creating the neighborhood file, we have to ensure that the distance between the points satisfy the commutative property. So these are the four rules that we have to keep in mind in order to create a neighborhood file. Now let us look at a small example on how to create a geo-referenced database. So assume there is a real world system that is collecting sensor data at different locations. Okay, so here we can see the sensors that are generating hourly PM 2.5 values at different points of time. These sensor data, using the domain knowledge, we can binarize it. For example, if the PM 2.5 values are greater than or equivalent to 35, we consider it as harmful recording and we create the binary dataset. This dataset, when we input it to any function, say geo-referenced transactional database function, what it will has to do is it will simply check the each line, and if a point has the value of 1, we represent it and in a file. So a point 00 has the value of 1, so we are storing that point. Point 10 has 0, means there is this point hasn't observed high levels of pollution, so we do not store this information, but we will store point 1 comma 0 because its value is 1. So in this way we create geo-reference transactional databases. So now let us look at a small demo on how to create a geo-referenced databases. So for that purposes, we will now open a terminal. In the terminal, let us create a file geo-referenced transactional database. So let us create a file with point information. In the next line, let us say 10 comma 10, 23.3 comma 19. Let us create another one. Point 10 comma. So in the similar way, we can create a geo-referenced transactional database and feed it to the pattern mining algorithms to discover patterns. Thank you very much for listening to our talk. If you like our work, please press the like button and subscribe to our channel for more updates. If you want to know more about georeferenced databases, please check the link provided below.